Hello everyone, this is Shashwat. Today we will learn about chap- our new chapter, Mystery of Matter. Every day we come across different things like animals, plant, human beings, water, chair, books, car, etc., which may be living or non-living. All these things differ from each other in one way or the other. Some vary in size, some in shape, and some in origin. Classification of matters. Let us name some objects around us: plants, animals, human beings, chains, table, water, paper, air. The list of objects or entities that we come across in our day to day life is infinite. However, it can be classified as living things and non-living things. The non-living things are made up of a wide range of materials. The chemistry deals with the study of these materials. Examples of materials: wood, glass, steel, metal, leather, con- concrete, cotton, etc. These materials differ with respect to various properties. Therefore, the materials can be categorized in many ways on the basis of different parameters like solubility in water, soluble in water, common salt, sugar, copper sulfate, potassium, permanganate, vinegar, oxygen, carbon dioxide. These all things can be dissolved in water, insoluble in water, chalk, powder, sawdust, sulfur, wax, nitrogen. These are these are not these can not be soluble in water. Appearance: lustrous metals, gold, silver, alloys, steel, brass. Alloys means in which the two elements mix and make a thing. Dull, wood and rubber. Lustrous means which shine. Dull means that not shine. Hard, metal and alloys. Diamond, glass. Soft, fiber, cotton, rubber, wax, clay. Transparency, transparent, glass, air, water, oil. Transparent means the things which can from which we can see outside that what is happening. Like sunlight comes from our mirror, that is a transparent thing. Translucent, oiled paper, tissue paper, muddy water, ground glass. These all things are translucent. From these materials we can see partially. 50% we can see, 50% we cannot see. Opaque, wood, metals, brick, stone, milk, fruit, juice. From these materials we cannot see anything. Density: float on water, wood, sawdust, oil, ice. Sink in water, iron, copper, silver, glass, stone. Float on water means the things which float on water, which has less density than the water. Sink in water means the things which are heavy than the water. Composition of matters: the common things that we absorb in all the above materials are: they possess mass, they occupy space. Anything that has mass and occupies space is called matter. Matter is made up of small tiny particles called molecules. That means molecules are the building blocks of matter. Molecules can be defined as the smallest particle of matter, which can exist independently and retain all the properties of the substance. Everything we see around us is made up of millions and millions of molecules, states of matter. Let us now see the various ways in which molecules can be arranged. Molecules are assumed to be hard surface. How does this arrangement influence the nature of the substances? The spaces between the molecules are called intermolecular space, and the force of attraction holding these molecules are called intermolecular force of attraction. Now, what is intermolecular space? Intermolecular space is a space in which the molecules have space between them. Like there is a molecule in ice closely packed, there is very little space. And in liquid, there is a bigger, more space. And in Z, there is very much space. So this means intermolecular space. Inter means inside the matter. Molecular means molecules. Space means space between the intermolecular for space. Now, what is intermolecular force of attraction? Intermolecular force of attraction is an attraction in which molecules attract them towards themselves. Like in X figure, solid are attracting themselves very tightly. That's why they are in tight shape in solid shape. In Y, the intermolecular force of attraction is loose, and in gas there is very loose intermolecular force of attraction. Inter means inside the matter, molecule means molecule, and force of attraction means the attraction between them. This closely spaced molecular arrangement imparts specific shape to the substance. Let us consider some solid such as metal, wood, chalk, stones, etc. Try to fill a cube with small spherical balls. The shape of the balls remains spherical, irrespective of the shape of the container, which means that solid has a definite shape. You can also find that definite number of balls can be accommodated in a container of fixed volume, which means that solid occupy definite volume. Liquid are categorized by loosely packed molecular arrangement as shown in Y and have larger intermolecular space and weaker intermolecular force of attraction. The molecules have slightly greater freedom of movement. Comparison of properties of solid, liquid, and gases. Property: shape, intermolecular force, compressibility, diffusion, density. Solid, definite shape, intermolecular forces strong, compressibility cannot be compressed, diffusion do not diffuse, density high. Liquids not definite takes the shape of the container. Intermolecular forces weaker than the solid, compressibility compressible to an extent, diffusion diffuse easily, density less. Gases shape not definite, intermolecular force weakest, compressibility easily compressed, diffusion diffuse easily and quickly, density very low. The figure Z represents very loosely packed molecular arrangement, which is categorized of gases. The number of molecules is much less than the number of molecules which can be accommodated in the space. The intermolecular space are very large with negligible intermolecular force of attraction. Example: the same amount of water is taken in three containers A, B, C. In all the cases, water takes the shape of container. The water fills the same amount of space in all the containers. Water taking the shape of the containers in which it is kept. It means that liquid has not definite shape. That means liquid occupy definite volume but not do not possess definite shape. Example, X and Y are two closed containers. The gas in X is transferred to Y, which is smaller in size than X in both the containers. The gas fills the entire space. The gas has no definite shape or definite volume. Interconversion of state of matter. We observe the following changes taking place in nature. When an ice block is kept on the table, you find that the ice block is reduced in size and water is formed. Ice block in Ice block is in solid state, water is in liquid state. Solid is converted to liquid as the ice block absorbs some amount of heat from the surroundings. The heat absorbed decreases the force of attraction between the molecules. The closely packed molecular arrangement changes to a loosely packed molecular arrangement. Heat when solid is heated, it changes into liquid. When liquid is cooled, it changes into solid. In this, the intermolecular force of attraction has been loosed because of the heating of surroundings. So the molecules of ice has absorbed the surrounding heat and they move faster and the intermolecular force of attraction loses. Changes occurring during interconversion of solid and liquid states. Closely packed molecular arrangement, loosely packed molecular arrangement, less intermolecular space, greater intermolecular spaces. Greater intermolecular force of attraction, lesser intermolecular force of attraction. The process of conversion of solid state to liquid state by heating is called melting or fusion. If you observe any solid on heating, it becomes hot and melts and melts on prolonged heating. Conversion of a solid to liquid thermometer container. As you can see that there is a candle below the container. So candle is heating the ice and the thermometer is showing the temperature of the ice. Conversion of solid to liquid state by heat. The actual conversion of a state from solid to liquid takes a place at a certain temperature. This temperature is called melting point. Melting point is defined as the temperature at which solid starts changing into liquid. Means melting point is a point in which the solid starts changing into liquid, like ice changes into liquid when it is heating. This process is called melting. When water is kept in a deep freezer in refrigerator for few hours, it gets solidified to ice. In this case, heat is taken out from water and the intermolecular force of attraction increases. The loosely packed molecular arrangement changes to the closely packed molecular arrangement. Like in the figure, uh, melting gaining energy means solid is gaining energy here. And now liquid is losing energy due to freezing because the refrigerator is mm, freezing the liquid and solid, and when we heat it, so the solid melts. Phenomena of melting and freezing. The process of conversion of liquid to solid on cooling is called freezing or solidification. If you Observe any liquid on cooling, it solidifies only on prolonged freezing. The actual conversion of a state from liquid to solid takes place at a certain temperature. This temperature is called freezing point. Freezing point of a liquid is defined as the fixed temperature at which a liquid starts changing into solid. The freezing point of a liquid is equal to the melting point of the solid. That means the freezing point equals to liquid point of the solid. Example: freezing point of water is 0 degree, which is equal to the melting point of ice. Let us consider water which is subjected to heating. Thank you.